Hello everybody, I am Mohammed Nabil, MET student at GUC, my ID 46-16585. Today we are going to talk about our DSD project. Our DSD project is an obstacle avoiding robot. I know it's a classic idea, but we add two major modifications. The robot is capable of scanning the surrounding environment using ultrasonic and servo sensors, and also is capable of receiving and transmitting data using the Bluetooth module. And we also implement a Java program that can visualize the gathered data from the Bluetooth, from the ultrasonic and servo, and also can send an instruction to the Bluetooth, which in itself sends the instruction to the FPGA to control the motors via the edge bridge. Firstly, we will talk about the Bluetooth module. We use the module HT05, which is a serial Bluetooth module that communicate via UART protocol. UART stands for Universal Asynchronous Receive and Transmit, which works asynchronously between the receiver and transmitter. So we had to oversample the received data to know the center of each bit. And we also implement a UART entity at the FPGA to interface the Bluetooth. We mainly use the Bluetooth to send an 8-bit data that encapsulates data read from the ultrasonic and the servo, and also receive the data instructions from the processing program to the FPGA to drive the motors.
Hello everybody, I am Mustafa Bakr. I am an MET student in GUC. I am going to talk about, my ID is 46-17080. I am going to talk about the ultrasonic sensor. The ultrasonic sensor consists of 4 pins, VCC, trigger, echo, ground. We used the ultrasonic to measure the distance at a certain angle. We generate a 20 millisecond pulse to the trigger, then we receive another signal from the echo. Then we calculate the flying time by using the time of the number of cycles when the echo is equal to 1. Then we map the flying time to the distance by using the equation of sound speed.
Hello, I'm Marwan Mohsen. I am MET student in the GUC. My ID is 4618972, and today I will talk about the servo in our DSD project. Simply, we use the servo with the ultrasonic in order to scan the surrounding environment for the obstacles. Servo is just a special type of motors which determines its shift or rotation from the PWM signal fed to it. Simply, our code consists of the entity and the architecture. Architecture consists of 3 main parts. For the entity, it uses clock and reset from the FPGA and surely the position of the servo in order to determine the PWM signal. For the architecture, we first have the generating process, which generates a counter we use to determine the duty cycles. And for the duty cycle process, we used it to just convert our place of the servo into number of duty cycles. The last process is the PWM process, which simply places a 1 on the PWM signal as long as our counter is less than the duty cycle. Thank you.
Hello again. Now we are going to talk about how the robot is working. Here we are sending data from the robot to the PC to plot it in 2D map. It is updated instantaneously, as we see. I put my hand and it appears here. We can send another data from the PC to the robot to move it, as we see. And we can reset the ultrasonic to begin from the beginning by pressing Q.
Now with some test cases, we set some obstacles in front of the robot, and I barely counted them, so we will depend on the plotting here to avoid these obstacles, first we set the position of the servo to scan from the left and wait until the robot is scanning. Barely there are some obstacles here and there, and there is a space between them in front of us, so we can continue moving forward. And we set the position of the servo. The position of the obstacle is updated like here and there, and still there is a space between them, so we can continue moving forward. Reset again the position of the servo. There is clearly nothing here, so we can continue moving. We wait until the servo is scanning the surrounding, and apparently there is something there. We wait until it returns, and there is an obstacle here, so we move right and continue moving.
So we placed two objects in front of the ultrasonic in order to see how it scans the environment. The objects we placed are on the left. There are the points on the left. So when it goes to the right, there are some points appears which shouldn't appear. This happens because of the noise in the environment. Also, when the ultrasonic is returning, there some shift may happen. As the reflected sound may happen some interference.